Okay, here we go. This is lesson 88, found on page 572. Today we're learning about transformations. We've dealt with those a little bit already. Those translations, reflections, and rotations, and that's something we'll build on quite a bit today. It says using those translations, reflections, and rotations to change the position of a figure in quadrant 1 on the coordinate plane. Okay, remember that coordinate planes are these x, y axis. Have these x and y axes. Coordinate or quadrant 1 is just located in the upper right. Remembering that these are the positive coordinates. Okay, if you have a positive x and a positive y coordinate, the point is found 1 to the right and 4 up. Alright, if you ever had negative numbers, they would lie in these other quadrants, but we're not worried about those right now. We're worried about quadrant 1. Okay, and next we will name the transformations that could be used to position one figure on another. If we look at page 573, it has our new concept. The new concept says, recall that two figures are congruent if one figure has the same shape and size as the other figure. One way to decide whether two figures are congruent is to position one figure on top of the other. The two figures below are congruent, and they look something like this. Okay? So what we need to do is figure out how we can shift this shape around and how we can translate it, reflect it, and rotate it so that it'll lie on top of this figure to determine whether it's congruent or not. To position the left-hand figure on the right-hand figure, we combine three different kinds of moves. First, we rotate or turn the figure a quarter turn. Okay? If we take this and we turn it a quarter turn, that's called that rotation that we see. Okay? Second, we need to translate this figure. Remember that translation doesn't rotate it, it doesn't reflect it. All it does is move it around on the coordinate plane. Okay? If we move that figure here, okay, it runs right into the side of our figure on the right. Alright, and the third way that we can move that figure is through reflection. And I'm going to block you here so that I can do it. Boom, figure reflected. It goes right on top of the other F, and therefore these two figures are congruent. Alright, and a little bit lower it says, recall that we had three different kinds of moves we made, and those are called transformations. And they're listed in that table right below on page 574. Again, translation, you slide the figure around, it doesn't rotate, it doesn't reflect. Okay, the second one is reflection. That's just like putting the figure in a mirror and just flipping the figure over a certain line. And then rotation, again, taking that figure and rotating it around. Alright, those are the three forms of moves. Below that, we have rotations can be described by their amount of turn and direction. If we have a figure and it rotates, okay, it rotates a quarter turn. Alright, of course, a full turn would be all the way around. A quarter turn would obviously just be 1/4 of the way. Alright, to the right, again, is clockwise. If we move it from the top to the left, it's counterclockwise. Again, this is a 4th turn. If we wanted to move it a half turn, we would obviously take our shape and move it 180 degrees like that. Okay, we often use degrees to describe an amount of a turn. One full turn is 360 degrees. All the way around that is 360. Half of a turn is 180 degrees. A quarter turn is 90 degrees. Okay, so if you only move it a quarter turn, okay, from here to here, that's 90 degrees. Okay, example number 1. And you'll want to fill out these examples on your sheets now. Okay, example number 1. It says the figure at right is the number 3. Sketch the figure 3 after a 90-degree clockwise rotation. Okay, so I have the number 3, and now it says sketch the figure after a 90-degree clockwise rotation. Okay, so I'm going to take my figure, rotate it 90 degrees this way, which is a quarter turn, and it looks something like this. Okay, we still have time. All right. Example number 2, it says triangles ABC and XYZ are congruent. Name 2 transformations that would move triangle ABC to the position of triangle XYZ. Okay? When we have 2 congruent triangles, wow, that's not very good. Okay, when we have 2 congruent triangles, okay, we can determine whether they are congruent or not, again, by translating, by reflecting, or by rotating those triangles and then placing them on top of each other. Well, how do we put these 2 triangles on top of each other? Well, the first step is to translate that triangle. Okay, it's not right on top of this triangle, so we need to translate it. We need to move it right beside it. Okay, after we do that, we understand that we've translated it, we've moved it directly to it. All we have to do now is rotate it. When it flips, it will be exactly on top of this other triangle, showing that the 2 triangles are congruent. If we would like to, you can of course reflect it and then translate it. The order of it doesn't really matter to me. Okay, so on your sheets, for example number 2, you would put reflect the triangle and then translate the triangle so that it lands right on top of this one. Okay, example number 3, triangles ABC and PQR are congruent. Describe the 2 transformations that would move the triangle ABC to the position of triangle PQR. Okay, so we have triangle ABC, and we have triangle P, Q, and R. Okay, how do we show that these 2 triangles are congruent by placing them on top of each other? Well, we need to take either triangle ABC or triangle PQR and rotate them first. Okay, we can rotate them 90 degrees. I would rotate triangle PQR 90 degrees counterclockwise. I would then translate it by moving it on top of this triangle. And that's not very good. But again, I don't expect our drawings to be perfect. Okay, lesson practice. Let's do lesson practice A first. Sketch an uppercase letter R after a reflection on its vertical segment. Okay, so I have R, and I need to draw it after it reflects on its vertical segment. Well, the vertical segment lies right here. Okay, so if I reflect it, it's just a mirror image of itself on the other side. Okay, so basically, I'm just drawing the R, but totally backwards, and that shows reflection of that uppercase letter R. Okay, B says sketch an uppercase letter R after a 90-degree counterclockwise rotation. Okay, so my letter R is here. I'm rotating it counterclockwise 90 degrees, and it ends up looking like that. Practice problem C. Name the transformation or combination of transformations that could be used to position triangle A on triangle B. Well, first of all, okay, for practice problem C, we have 2 triangles that share a vertical line segment. So again, if you wanted to show that these 2 triangles were congruent, you would take and reflect triangle A so that it would be on triangle B. So for letter C, we show reflection. Okay, practice problem D. The shapes look like this. How do we get triangle A to show that how do we show triangle A is congruent with triangle B? Well, we take our triangle A and we rotate it we rotate it 90 degrees in a clockwise direction. Okay, but the only thing you need to write down for letter D is rotation. Okay, all we're doing to get triangle A, to show that triangle A is congruent with triangle B, we're using rotation. Okay? Okay, practice problem E. We have two triangles. They do not share a vertical or a horizontal line, so we can't use reflection right away. Okay? But how do we show that triangle A is congruent with triangle B? Well, first, we could take triangle B and we could, oh, you would, and we could rotate it. We could rotate it 180 degrees and we would show that it's congruent with triangle B. Okay, there's another way you could do it. You could also rotate it. You could also use rotation. If you rotate it, come on. Okay, if you use rotation, it might not land perfectly on top of it, so you might need to use some translation by shifting it right on top of triangle B. Okay, and finally, practice problem F. Okay, practice problem F. Our two triangles lie a slight distance away from each other. Alright, and there are many different ways that you can show that these two triangles are congruent. One way, I'll draw another one. Okay, one way I guess that I kind of come up with, these two are touching here. One way would be rotation and then reflection or translation, and then once they share that vertical axis we can use reflection. Okay, I guess sorry if that confused you at all. Feel free to rewind the video, pause the video, do whatever you have to learn it. Again, I'll see you tomorrow, which is Thursday, and we don't have school Friday, so excellent. Hopefully we did better today than we did yesterday, and I'll see you later.